Hello and welcome to another video on quantitative chemistry where we are going to be answering a question in the amount of substances. Now today we're being asked to calculate the total volume of gases present after the reaction. Okay, so we know what we're given. We're given 30 centimeter cubed of Si2H6, which is reacted with 150 centimeter cubed of oxygen, which is in excess. Now this is very, very, very important. Now, a lot of students may think that, oh, I need to work out the moles, I need to work out the concentration. You don't need to work out any of that. Really, it's simply just down to using ratios and a little bit of subtraction. It's not as complicated as you may think it is. On the left side, I'm going to write a volume, and this is how we will track how much volume is used in the reaction and how much we have at the end. So we're already told that in our reaction, there is 30 centimeter cubed of Si2H6, which is going to be used. So this is the volume that we're given already. Now, we're also told that it's reacted with 150 centimeter cubed of excess oxygen. So that means that not all of the oxygen is going to be reacted. Only some of it will react, some of it will be left over, which will be part of the total volume of gases present after the reaction. So what we need to do is we need to use ratio to find out how much of the oxygen is used in the reaction. And the way we do that is we look at the numbers, the ratio of the numbers before each element and compound. We can see that before Si2H6, before this compound here, we have 2. Before oxygen, we have 7. That's in the ratio 2 to 7. And at the bottom, we have 30. And we don't have anything here, which is what we're trying to find out. So to get from 2 to 7, you times by 3.5. So the same thing to find out what x is, times 30 by 3.5, and that gives us 105 centimeter cubed. So that is the volume of oxygen that is used in the reaction. Using this, we can work out how much oxygen is left after the reaction. How much wasn't used? By simply taking the 150 that we started with and minusing it with what is used. 150 minus 105 gives us 45 centimeter cubed as what is left of the oxygen. However, that's not it. And many students get tricked by this part because that is not all. Take a closer look because at the product, we have water vapor, and water vapor is a gas. You can see through the symbol. And because of that, it is counted as part of the total volume of gases present after the reaction. So we have to also find out the volumes of water vapor. The way we do that is simply the way that we found out the volume of oxygen that was used. We use ratio. We use the 30 centimeter cubed again, and this time it's in the ratio 2 to 6. So to get from 2 to 6, we times by 3. So that's what we're going to do with 30. 30 times by 3 gives us 90 centimeter cubed. So the volume of water vapor that we have produced is 90 centimeters cubed, which adds on to the 45 centimeter cubed of total volume of gases present. So 90 centimeter cubed, add 45 centimeter cubed, gives us 135 centimeters cubed. And that is how you find out the total volume of gases present after the reaction. So the main point to remember is that you find out how much oxygen was used in the reaction, and then you find out how much was left. And then you use the same method to find out how much volume of water vapor was produced, because that is still a gas, and that counts in the final answer.